Greetings. Welcome back. We are now in session 7, part 2. In session 7, part 2, we are in the stage of discussing decision trees. Very important, extremely simple topic, but I want to make sense of it. I don't want to just throw at you the numbers. With that in mind, let's take a look at the decision tree in general and see what it is. You make decisions all the time, every day, from morning to evening, and potentially in your dreams. This is a simple decision tree that you could potentially make. Suppose you have had a job offer and you have a threshold of the salary. It could be 120,000 with today's environment, but let's call it 50,000 at the moment. If the salary threshold is not met, and that's an attribute, you could say, I'm going to decline the offer. If the salary threshold has met, you're going to go into another attribute, and that's the commute. And the commute, if it is from the rental place you have to the place of work, if it is more than 1 hour, you're going to decline the offer. If it is less than an hour, potentially even half of that, you're going to consider the perks of the company. In many companies in the west of USA, in California, they offer you breakfast, lunch, potentially dinner, lots of snacks, open kitchen. You potentially want to look at the perks. If there are no perks, you don't want to take it because obviously perks add up in terms of cost. If they are offering you perks, you're going to accept the offer. This is a simple decision tree. Let's try this one more time. Take a look at buying a car. Maybe your primary attribute that you would like to have for your car is the color. If this is really the main attribute that you're looking for, you're going to say, is this red? If it is yes, you're going to take a look at the model. If it is more than 2010, which means quite recent, in the past decade, I would say, you're going to buy. If it is older than 2010, you're going to take a look at the mileage. And if the mileage is less than 50,000 kilometers, it means the car has not been in use as much or as frequently. You're going to buy it. And if it is more than 50,000 kilometers, you're going to decline the offer. Now, if the color is not red, you are still in the market. You would like to see whether it's yellow or not. That's your substitute. That's the second option in terms of color. Then if it is yellow, you might want to consider whether it's a Ferrari or not. If it is Ferrari, you're going to buy it. If it is not Ferrari, you don't want to buy it. And if it is not yellow altogether, you wash your hand and you get out of the showroom. So you don't buy the car. This is another simple decision tree. Let's take a look at this one. Should you buy or should you rent? Today, market is extremely hot in terms of property. You could potentially say, ask yourself a number of questions. Are you going to stay more than 5 years or less than 5 years in a place of work? You're going to move to a state, you're going to move to a specific city. Are you going to stay there more than 5 years? If it is yes, are you financially stable and you have a good salary and it is a kind of a 2-3 years contract, when you're a tenured position and so on? If it is no, you're going to rent because you never know what's happening, right? If it is yes, you're going to take a look at your numbers. Do you afford to have a mortgage? Is the budget that you have, you can handle the mortgages, the taxes, maintenance, and other costs? If it is yes, you're going to buy it. If it is no, you're going to rent it. Similarly, if you're not planning to stay more than 5 years, maybe 3 years, 4 years, you're going to basically still investigate potentially whether you can handle. It may be a case that you're going to be there for 3 years, a contract, and then are you going to be able to handle the mortgage? If it is yes, you buy it. If it is no, you rent it. It's a simple decision-making process. You turn on your computer and you see that the computer peacefully turns on, the operating system kicks in, you get back to your desktop after entering your user ID and password, and everything is functioning properly. Bravo, it's done. You go ahead and you do the daily work you need to do with your computer. If the computer is not turning on, you're going to see whether something is wrong. Maybe the battery has died down. You're going to go through stages of examinations. And those stages of examinations, you're going to make a decision whether you need to take it to the repair shop or perhaps you're going to replace battery, a dead battery, a dead adapter, and then basically fix the computer by yourself. This is something you do all the time. Do you want to go to the classroom today? Maybe it's early in the morning, you're tired, you didn't have a good night last night. And even if you go to the classroom, you may not be able to digest the material properly as your brain is fuzzy and dizzy. Did you have illness in the past? Do you have fever? The fact that you have if else all the time, it means you're looking at conditions, and those conditions you have to make a decision. I think I'm making sense on this. Now, with that being said, still I want you to make a sense of the calculation we are going to discuss in a moment. I want you to consider the I want you to consider this case. You want to buy a cookie. You have had cookies since you were 1 year old, 2 year old, right? And you know the taste, and you know the goods, and you know the bads, and you know you may like the chocolates. Many people like chocolates. In your case, you may actually um, uh, uh, like a simple cookies with lots of sugar drops on it. Whether it's safe or not, or healthy or not, that's a different discussion. But this is the type of bag you want to go and buy. When you take a look at the bag, what do you notice? You notice that all of the three cookies inside are of the same size, are of the same nature and taste and everything else. It's homogeneous. It is exactly the same, I would say, in this case. If you take a look at this cookie or this cookie, they are exactly the same. It's called homogeneous. Now, if I ask you to take a look at this cookie, you're going to scratch your head a little bit. You're going to say, listen, it is a combination of so many, and I like this one, and I don't like this two. I like this one, and I don't like this one, right? So you're going to actually think about it. Do I have to buy this jar of cookie or not? Do I have to buy this bag of cookies or not? And that becomes something that you need to decide. Now, let me give you another example. I think yeah, this is another example. And this has happened to me many, many times. You happen to go and buy basically a bag of nuts. For example, this one, right? You go and buy a bag of nuts, and you have everything is good, everything tastes good. You have a yes, 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 yes. It is perfectly classified as a yes in your mind, and then you go and you buy. There is a small nut that when you put it in, it tastes very bitter, and it actually destroys everything else. But at the same time, you say, listen, I'm going to buy this bag. 99.99% of the bag is good. I'm going to take it. And a mixed bag of nuts. This is another example, right? So what are we trying to do here? We are going, is it easier for you to make a decision when you are facing with a homogeneous bag? It's very easy. All of them are cookies, the same type. You have tasted them, whether you like them or not, yes or no. It's just one yes and no. There is no ambiguity. Decision is done, is clear, finished. However, about cases like this, we are going to be a little bit hesitant. But at the same time, as I said in another example, if you like four of the cookies and you may not like the other one, you're going to still take a look at this bag of cookies. So it may not be necessarily entirely the 100% the cookies that you like, but 4 out of 5 you like them. So the yes is 4 out of 5, and the no is 1 out of 5. This is what we are trying to explain. So if it is homogeneous, how do we, now in terms of data, we do have a lot of data, small and large, and we want to translate this understanding to numerical approach. And for numerical approach, we discuss something, and we call basically entropy, okay? So we are going to talk about entropy. Now, before we do the entropy, before I forget, we are going to formalize the tree itself. It's going to have a root node at the very top. When we say it's a root node, it means it's just the beginning, there is nothing behind it, and that's the moment you are going to start to make a decision. You're going to have branches, as you realize in several examples we had. You're going to have basically two types of nodes at the end. There is going to be a leaf node, which is a kind of a terminating node, where you're going to make a decision and everything is done. And there could be, this is a square most of the time, and there could be a circle at the end, and still this is a leaf node because there is nothing to do afterwards, but it not be necessarily a perfect decision, and it could be left to chance. So you could potentially take it or not. So that's something we will discuss at a later stage, at the advanced stage. But at this time, I want you to remember that a tree has this structure, that the tree has the structure going from the top and going down to the stages, to the basically to the terminating nodes. Okay. Now, in order for us to understand what this is, I want to talk to you about entropy. So remember, we want to target the homogeneity. All the cookies are the same, or if not, they are not the same. How much of them, how many of them are going to be on one side, the yes side, and how many of them are going to be on the no side? Yes side means you like them, you tasted them in the past. No means you don't like them and you taste them in the past, but you didn't like them. So it would be 4-to-1. It's not a pure bag. Another terminology data scientists use is called pure. So when I have a bag that has all the cookies are exactly the same, it's a pure bag. When if I have a bag that all of the cookies inside the bag is something that I like and I assign yes to all of them, we call it pure bag. But the impurity kicks in when I have a bag, 4 of them is yes, 1 of them is no. And the one that is no is considered impure. Obviously, decision is going to be made quite easier if it is going to be more pure or less impure. So this is the way we want to take. We want to say, can I move toward the decision where I would say, this is actually more is more evident, more obvious to buy this bag with 4 yes and 1 no. You're short of cookies, you have a cookie rush, and you want to buy it. You don't have the perfect bag with all of the cookies in it that you like. Yes, 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 yes. You have 4 yes and 1 no. This is called impurity. When you have one cookie that you don't like, it's a no, right? Now, take a look at this one. Basically, when you have all of the cookies exactly the same, once again, let's take a look at this cookie jar. If you take a look at this cookie example, if all of them are the same, when you put your hand inside and you pick up one of the cookies, what's the probability that the cookie you picked you like? It's going to be 1. So the probability of picking a cookie that you like inside a bag that is homogeneous and you know you like it is going to be 1. Now take a look at another one. Maybe, and just maybe, I don't like the type of chocolate cookies. This is homogeneous. You don't like them, it's a no. Remember, all of that is no. But what's the probability of you putting your hand inside the bag and pick up the cookie and say, this is I don't like? The probability is 1. So when the bag becomes homogeneous, the probability is going to be 1. With that in mind, and of course, when the bag is not homogeneous, such as the example we had on this case, then the probability is going to be different. So you said 4 yeses and 1 no, so it's going to be 4 divided by 5. So that 4 divided by 5 is the probability of putting your hand inside the jar and picking up the cookie that you like. That's the probability. Very easy to calculate. Agreed? Now, with that in mind, let's identify a metric, a measuring tool for us, and that is called entropy. Excuse me. As we said, basically, when you have the when you have everything homogeneous, what happens? Everything homogeneous. Whether you say yes as in 1, whether you say no as in 0, what is happening is that you're going to take the log, and the log of the probability. Probability is 1. So the log of probability is going to be log of 1, regardless of the base. It's going to be 0, multiplied by any constant is going to be 0. So when it is homogeneous, you're on this edge. You are on this edge. Okay? Log of 1 is 0, and basically the entropy becomes 0. So for homogeneous bags, the entropy is 0. Now, imagine this point. You have a bag, you have 5 cookies you like, and you have 5 cookies you don't like, equal. And if you consider that in mind, what's the probability of selecting a cookie that you don't like or you like? 5 like, 5 dislike, total number of cookies in the bag 10, 5 divided by 10, 5 divided by 10, that's going to be 0.5. So if you apply 0.5 log of base 2 of 0.5, remember 0.5 means 1 over 2. And that's the reason we chose base 2. When we say 50-50, that means base 2. We are dividing into. So when we say log of 1 over 2, and if the log base 2 is going to, if log is based on 2, log of 1 over 2 is going to be basically minus 1. So minus 1 times the half of the minus is here to cancel out the minus sign. So half is half cookie yes, half cookie no, half cookie yes, and half cookie no together. That's going to be your 1. So if you have a bag that is 50-50, you're going to scratch your head and say, I don't have easy time to actually select it. Should I buy it? I have half of the cookie that I like. Should I not buy it? I have to basically put the other half perhaps in the fridge, give it to a friend, and worst case, trash it. Should I buy it? Should I not buy it? So when the entropy is 1, your decision is going to be very difficult to make. Now, let's consider another scenario. Suppose you have 10 cookies in a bag, and you have 8 cookies you like, and 2 cookies you don't like. Okay, so what's the possibility of you picking up the cookie that you don't like? That's 2 over 10. What's the possibility that you will find a cookie that you like? That's 8 divided by 10. So I'm going to do log 2 of 0.2, 2 over 10, log 2 of 0.8, 8 over 10. I'm going to multiply log of 2, 0.2 by 0.2, log of 2, 0.8 by 0.8. And when I calculate this, it actually gets a number. It's going to give me a number. And that number is going to tell me whether the decision is going to be easier to make or not. And obviously, the closer you become to 1, the closer this number is going to be to 0. And as you can see, you are actually reduced the impact of this one. And therefore, this is going to be closer to 0, meaning that the decision is going to be easier to make. What are we trying to do? We are trying to take a look at the entropy. And this entropy is going to be a factor in our decision-making process. A few points that you need to keep in mind when we are talking about decision tree before I actually go into technicality of the case. First and foremost, it is actually exploring all of the attributes in the table you have. You could have short table, you could have long table, a large table, whatever table you want to make a decision on, that table, everything is going to be explored. And at some point you will get to the very end. And when you get to the very end, you are going to make a decision to go for it or not to go for it, okay? It is kind of exhaustive. It is very simple at the same time because really it's just a matter of fraction. Say you have the log of 2, that would be the most computational part, and scientists and researchers have tried to actually simplify that using a different tool. We are going to talk about it in a moment. But generally speaking, it's really simple. It's just a bunch of fractions and a bunch of logs. And if it is just 1 or 2 branches, you can even do it by your calculator. You don't have to worry about the execution time. You really don't need to have expert knowledge, domain expert in this case. It's just whether you are you're selling food and basically groceries, or you're selling houses, or you're selling the tickets to the moon. Doesn't matter. Is this your area? Are you trying to do anything very unusual that you haven't seen in the past? It really doesn't matter, because as long as you know that the table is in front of you, all you have to do is actually do these branch and bound all the time. Of course, the expert knowledge comes in at the stage where the table itself is prepared. So the table itself has been prepared by someone who has the domain knowledge, and that's a different topic. But if the table is in front of you, even if you're a high school student, you should be able to do it. With that in mind, we spoke of the entropy. Now, take a look at the entropy. I'm going to talk to you about the entropy in a moment in the next recording. Thank you and stay tuned. We are still in session 7. We will continue part 2. I was just trying to make sense of what the process is. I didn't want to just punch in numbers without understanding what the numbers come from, where the number come from. So please listen to the next stage where we go a little bit into calculation now.